So I'm continuing. It seems to be extra long, so I'm breaking it into parts. An arch is built so that it is 6 feet wide at the base. Its shape can be represented by a parabola with the equation that, where y is the height of the arch. Graph the parabola from 0 to 6 on the grid below. So it's specifically telling me from where to graph it. So really it's telling me the domain over which to graph it. So they don't want me to put arrows. And I would just use my calculator and write down the table of values that goes with this equation. Negative 2x squared plus 12x. And they want me to graph it from 0 to 6. So 0, 10, 16, 18. 0, 10, 16, 18. And then plot these points. Oof. Hate this. So no arrows, since they told me over which domain to graph it. If they ask me for the range of this, just throwing it out there in case it's asked, the range over this given domain is from 0 to 18. Right? I could ask you the range of a function given a certain domain, or vice versa. Anyway, it says determine the maximum height. So it's 18. 18 what? I don't think it gives me units. Oh, feet. 18 feet. Number 11 is like a blast from the past. This is not quadratic. Please remember, I know we're in a quadratic unit, but I'm always going to give you review questions. You have to recognize what kind of equation you're given. This is linear. It actually happens to be a literal linear equation because it's more than one variable. So I got to get x by itself, so let's add 3 to both sides. And you're left with ax minus 4x equals 13. I can't combine these though, and I'm trying to solve for x. So we learned that you can undistribute, and that was back in September. And now, undistributing, we've actually been calling factoring. So if I take out the GCF of x, I'm left with a minus 4 in parentheses, and I can divide both sides by the a minus 4. So x equals 13 over a minus 4. And that's the best I can do. There isn't anything else to do. Letter G, number 12, I have to solve for G. If you don't know what to do here, does that give you a hint? I would hope so. If it doesn't, does this give you a hint? I hope that did it. We will look at this as a proportion and do cross products. There are other ways of doing it, but this is the way that I've always done it. With you, that is. I am trying to solve for G, but the G's are on two different sides, so I'd like to get them on one side, but since this G is caught up in parentheses, I have to distribute. I don't always distribute in literal equations, but in this case I have to, because the G is caught in the parentheses. Because now I can subtract the RG from both sides to get the G's to one side. I'm coming over here. So RS equals GS minus RG, and now I can undistribute, and I can divide by the S minus R. So the final answer is RS over S minus R. That cannot be simplified any further. You cannot cross out the R's and cross out the S's. It just cannot be done. Can't be done because you can cross out common factors, but in the denominator, these things aren't factors, they're terms. Factors are separated by multiplication signs, not subtraction signs. Jack is building a rectangular dog pen, so let's draw a rectangle that he wishes to enclose. I guess he's putting like a fence around it. That would be the perimeter. Anyway, the width of the pen is 2 yards less than the length. I don't know the length. 2 yards less than would be an x minus 2. And if the area is 15, I know that area of a rectangle is length times width. I know that this is quadratic because when I multiply through, I get an x squared. I know what quadratics, I got to get set equal to 0. And then I know I have to factor. First thing I look for is a GCF, but there isn't one. So this factors into the product of two binomials. I want things that multiply to be a negative 15, whose outers and inners are a negative 2. So how about a negative 5 and a positive 3? Once I factor properly, I set each factor equal to 0. And I solve each linear equation separately. So x is 5, or x is negative 3. X is a dimension of a rectangle, can't be negative, it gets rejected. So how many yards of fencing would he need? So I know that this is 5 yards, and 5 minus 2, this is 3 yards, and the opposite sides are equal, so he would need 16 yards of fence. Find 3 consecutive odd integers. Let's let x equal the first odd. Odd integers are 2 away from each other, so x plus 2 is the second odd, and then x plus 4 is the third odd, such that the product of the first and the second, so the first one times the second one, exceeds the third by 8. So here's the third one. So this product is bigger than that by 8. So I'm going to give this 8 more so that they're equal to each other. So the exceeds problems, just take a moment to think about where you need to put that additional number. And now we'll distribute. And we'll combine like terms. And it's quadratic, so we'll get a set equal to 0. And since it's quadratic, we'll factor. There isn't a GCF, so I'm doing a trinomial. Things that multiply to be a negative 12, whose outers and inners are a 1. This works out. Set each factor equal to 0. Solve each linear part. X is a negative 4, x is a 3, x is an odd number, so I'm going to reject this. I'm not rejecting it because it's negative, I'm rejecting it because it's a 4. So if the first one is 3, then the next one is 5, and the next one is 7. Sometimes when we're doing these word problems that aren't about dimensions or about odd, even, positive, and negative, sometimes both answers are valid. So sometimes we have 2 sets of answers that are good. And when we were doing our lessons, like lesson 9, I think it was, and 10, Look back at those. Look back at the answers that I gave you. Some of them have two sets of answers, and you have to write down both sets in order to be accepted. Number 15, the area of a rectangular playground. So again, a rectangle can't have negative dimensions, so we'll probably reject something. And the area is 500. The length is 5 meters longer than the width. So I don't know the width. This is 5 meters longer. Find the dimension. So length times width equals 500. Distribute. Get set equal to 0. Factor. First look for GCF. There isn't one. It's a trinomial. If you can't think about the factors of 500, let's go over the trick that I taught you in your calculator. In your y equals, you will do 500 divided by x and go look at your table of values. And we can see things that multiply to be 500. 1 and 500, 2 and 250. We ignore the decimals. 4 and 125, 5 and 100. Remember, we're trying to find things whose outers and inners will be a 5x. So I'm going to keep on looking through this until I see something that I feel like trying. I don't always just try the first thing I see. I look through them. Oh, I see it. A 20 and a 25. Things that multiply to be negative 500. 20 and 25. If this one was positive and this one was negative, that should work. Let's see. Outers are a 25x. Inners are a negative 20x combined to be a 5x. I'm confident. So now I set each factor equal to 0. Since it's dimensions of a rectangle, this one gets rejected. Find the dimensions. So that's both the length and the width. If this is 20, this is 20 plus 5, which makes it 25. The dimensions are 20 meters by 25 meters. Almost done. I made this video before and it didn't save, so I'm getting a little tired here. I've been doing this for a couple hours. This is an important one. You have to put your thinking caps on. I wouldn't say it's hard, but you just have to think for a moment. So Deborah built a box by cutting 3-inch squares from the corners of a rectangular sheet of cardboard. So this picture here is a rectangular sheet of cardboard. These grayed in areas are the corners that she cut out. And if she cut out these squares, these white rectangles on the edges, if you fold them up, they'll meet. It'll kind of look like a shirt box. You know, if you were giving someone a present and you put it in a box, there's like a top and a bottom to a box. So the box could look something like this. There you go, there's my artistic abilities. So this is like a box, you know, an open box without a top on it. You could put like a gift in here and close it and wrap it. And that box is created by pulling out these corners. Now you can see on here that the corners that got pulled out are 3 by 3. So that means the height of this gift box here is 3 inches. So let's keep on reading. The volume of the box. So volume is length times width times height. So of this box that I drew, the volume is 150. The longer side is 5 inches more than the shorter side. So I'll call this the shorter side. I'll call this one the longer side. We already know that the height is 3 inches. So volume equals length times width times height. They told me the volume is 150. So 150 equals x times x plus 5. I'm going to put this in parentheses too, times 3. There are 3 things being multiplied. When we multiply, though, we only multiply 2 things at a time. So I'm going to multiply this first and get x squared plus 5x. This is a binomial that's being multiplied by this 3, so now I'm going to distribute that, and I get 3x squared plus 15x, which equals the 150. It's quadratic because I see an x squared, therefore I have to get this set equal to 0. So now I have 0 equals 3x squared plus 15x minus 150. There is a GCF of 3, so I'm left with x squared plus 5x minus 50. I'm sure this trinomial can be factored, because otherwise I wouldn't know how to solve it. So x and x, things that multiply to be a negative 50, whose outers and inners are 5. How about a positive 10 and a negative 5? The outers are a negative 5, the inners are a positive 10, those add to be a positive 5, and of course those things multiply to be negative 50. I'm going to come back over here. So I have 3 times x plus 10 times x minus 5 equals 0. 3 factors equals 0. Does 3 equal 0? No. Maybe x plus 10 equals 0, or maybe x minus 5 equals 0. When I solve this, I get x is negative 10, and when I solve this, I get x is 5. These are dimensions of a box, can't be negative, this gets rejected. So I'm going to go back up to the box I drew. This is a 5, this is a 10, because 5 plus 5 is 10. If I were to multiply it, 5 times 10 times 3. I'm going to do the 5 times 3 is 15. 15 times 10 is 150. And yeah, they told me that the volume is 150. So I'm confident that my numbers are correct. But let's answer the question. They asked me to find the number of inches in the shorter side of the original sheet of cardboard. I have to go back to this drawing they gave me. The shorter side is not 5. That 5, it's in that picture that I drew in blue. That 5 is this right here. From here to here. Don't forget, the original side is a little longer than that. There's a 3, then there's a 5, then there's 3 more. So this turns out to be 11. 11 inches. If they were asking me for the other side, they're not. But if they were asking me for this side, it's a 3 plus a 10 plus a 3. 3 plus 10 plus 3 is 16 inches. The answer to this question, though, the shorter side of the original is 11 inches. I'm almost done. Graph the equations. I wish it said graph the functions. Whatever. Functions are equations. State which equation is linear, exponential, and quadratic. And then which function has the greatest average rate of change in the interval from 0 to 2. So they do have to give me an interval because remember the rate of change is not constant in quadratic equations and they're not constant in exponential. The only thing the rate of change is constant in is a linear. And by looking at the equation, I could see f of x is the quadratic because there's an x squared. And the second one is linear because it's in the form of y equals mx plus b. The exponent of x is a 1, definitely making it linear. And then if x is an exponent, that's what makes it exponential. I'm going to graph g of x first because it's linear. I don't need a calculator for that. I can easily see that the slope is 3 and the y-intercept is -5. I'm going to have my x and y axis go by 1, so I'm not going to label it. If you don't label it, it automatically means you're going by 1. I'm just going to start at 1. I'm just going to zoom in a bit. This is a little too small for me. 1, 2, 3, 4. Now the y-intercept is at -5. And we said the slope was 3. 1, 2, 3 over 1. 1, 2, 3 over 1. 1, 2, 3. I have a really hard time drawing with this pen. This is g of x. F of x I'll do in red. And I need a table of values in order to graph it. X squared plus 2x minus 1. 1. Look at your table. Go find the symmetry. Found it. From -4 to 2. Uh, 7, 2, -1, -2. 7, 2, -1, -2. And then it's symmetric. And I can graph it. This pen is so hard to use. This is f of x, and h of x I guess I'll do in green. This one I know is going to have a horizontal asymptote. I know that it like approaches something but never touches it. In this case it's going to be the x-axis. 2 to the x. You could see that this function is constantly doubling. It makes sense because the growth factor is a 2. It tells us that I keep on multiplying things by 2. And I always graph the non-decimal numbers first. So 0, 1, and then 1, 2, and it's doubling, so it's going up to 4. It's doubling, so it's going up to 8. It's doubling, so it's going up to 16. If I go the other way, it's going in half. So I just be very careful with this side. It's so hard with this pen, actually. Remember, it doesn't touch the x-axis, just gets really close to it. So I graphed it. I stated which is linear, exponential, quadratic. And finally, I have to do the average rate of change. Remember, when I ask for the average rate of change, I'm really asking you for the slope between two numbers, between 2 points. If you have 2 points, you're going to use y2 minus y1 over x2 minus x1. So the 2 points, the first one starts with a 0, while the second one starts with a 0. I'm talking about the x value. The x value is a 0, and the x value is a 2. So I'll do 7 minus negative 1 over 2 minus 0. So this is 8 over 2. This rate of change is 4 over the interval 0 to 2 for function f. This next one, 4 minus 1 over 2 minus 0 is 3 over 2, which is the same thing as 1 1/2. The rate of change for h of x from 0 to 2 is 1 1/2. And then for g of x, I could see this point is 0, negative 5. I could see that this point is 2, 4. So if I do the rate of change, I could do negative 5 minus 4 over 0 minus 2. 1, 2, 3, 4. And I get negative 9 over 2. I did something wrong. 1 more. Rate of change is supposed to be 3. I'm so silly. This is not the point 2, 4. This is where x is 2. This is the point 2, 1. I knew I was making a mistake. I knew the rate of change was the 3. So we all make mistakes, and I guess that's why it's so good to be able to look at a question from all different views. I knew that this rate of change was turning out wrong. So I found my mistake at least. So we have negative 5 minus 1 over 0 minus 2. Negative 6 over negative 2 is 3. Shoo! Alright, so which rate of change is the greatest? Well, 4 is the biggest. So f of x has the greatest rate of change. Over the interval from 0 to 2. It's important that you state that it's over that interval. F of x doesn't always have the greatest rate of change. At different spots on the graphs, other functions have a greater rate of change. But anyway, hope this was helpful. Hope you do well on Monday. There's extra out Monday morning if you need it. Enjoy the rest of your weekend. See ya. Bye.